Imagine being a scientist in Antarctica in the 1980s, braving the relentless cold and isolation, tasked with measuring the invisible gases in the sky above the coldest, most remote place on Earth. Every day, these dedicated researchers faced extreme conditions, driven by curiosity and a sense of duty to understand our planet's atmosphere. For years, a small but determined British Antarctic Survey team used Dobson spectrophotometers, specialized instruments designed to measure ozone in the atmosphere, to monitor the ozone layer. They expected to see steady, predictable readings as they had for decades, believing the ozone layer to be a stable shield protecting life on Earth from harmful ultraviolet rays. But then, quite unexpectedly, their data began to reveal something alarming. Each spring, the ozone levels above Halley Bay were not just dipping, they were plummeting at an unprecedented rate, far beyond what anyone had anticipated. At first, the team suspected their equipment might be malfunctioning. After all, such dramatic changes seemed impossible. To be certain, they brought in new instruments, meticulously calibrating and double-checking every reading, determined to rule out any error. The new readings, however, only confirmed their worst fears. A massive chunk of the ozone layer was vanishing every spring, creating what would soon be known worldwide as the ozone hole. This was not a minor fluctuation, but a dramatic and dangerous loss. This was a catastrophic loss, not just a small dip in the data. The implications were staggering. Without the ozone layer, life on Earth would be exposed to far more ultraviolet radiation, increasing risks for humans, animals, and plants alike. The discovery sent shockwaves through the global scientific community. It was as if someone had found a giant, invisible hole in the planet's protective roof, threatening the safety of all living things. Immediately, scientists around the world began collaborating, racing to uncover the cause and understand the full implications of this mysterious phenomenon. The urgency was palpable. Everyone knew the stakes were incredibly high. Meanwhile, NASA satellites had also been collecting data over Antarctica. Strangely, their computers had dismissed the extremely low ozone readings as errors, assuming such drastic drops were impossible. But once the British team published their findings, NASA scientists quickly re-examined their satellite data, this time looking for the very anomalies they had previously ignored. The resulting images were stunning. They revealed a vast, gaping void over Antarctica, perfectly matching the ground-based discovery and confirming the terrifying reality of the ozone hole. The world now faced a major environmental crisis, one that demanded immediate attention and action from every nation. Scientists and governments alike realized that urgent, coordinated action was needed to address this unprecedented threat to the planet's atmosphere and to human health. The ozone hole mystery had become a global emergency, sparking a new era of international cooperation and environmental awareness. The ozone layer is Earth's natural sunscreen, a thin, powerful shield in the stratosphere, 15 to 30 kilometers above us. Made of ozone molecules, O3, it absorbs about 98% of the sun's harmful UVB rays. Without it, life as we know it wouldn't exist. UVB radiation can cause skin cancer, cataracts, and weaken immune systems in humans. Animals and even tiny ocean plankton are also at risk from increased UV. Plants, too, suffer. Too much UVB damages their cells and stunts growth, threatening agriculture worldwide. The ozone layer's health is directly tied to the health of every living thing on Earth. That's why the discovery of the ozone hole was so alarming. It's a silent guardian, making life on the surface possible. Protecting it means protecting ourselves and the planet's ecosystems. Its fragility is a reminder of our responsibility. After the ozone hole's discovery, the world united to act. The Montreal Protocol of 1987 banned the use of CFCs, chemicals found in fridges, air conditioners, and spray cans. Did it work? Yes. Scientists have watched the ozone layer slowly heal. NASA and NOAA track the ozone hole every year, and recent data shows it's shrinking and becoming less severe. The healing isn't a straight line. Weather and rare events can cause temporary spikes, but the long-term trend is positive. If we stay on course, the ozone layer could fully recover by 2066. This is one of the greatest environmental success stories ever. It proves that global cooperation and science can solve even massive problems. The recovery isn't finished, but the signs are clear. Our planet's invisible shield is mending. It's a hopeful example for tackling other environmental challenges. The ozone layer acts as Earth's natural shield, protecting all living things from ultraviolet or UV radiation. These are powerful, invisible rays that constantly stream from the sun and reach our planet every day. There are three main types of UV rays: UVA, UVB, and UVC. Each type has different effects on our health and the environment. The ozone layer completely blocks the most dangerous UVC rays and most UVB rays, but it allows most UVA rays to pass through to the surface, which is why we still need to be careful. UVB rays are the main culprit behind sunburns and play a major role in the development of skin cancer, making them especially harmful. UV rays act like tiny energy bullets, penetrating the skin and damaging the DNA inside our skin cells. Over time, this damage can lead to premature aging, wrinkles, and even cancer. The UV index is a daily tool that tells you how strong the sun's rays are in your area, helping you plan your outdoor activities safely. Don't be fooled. UV radiation can be intense even on cool or cloudy days. It also bounces off surfaces like water, sand, snow, and concrete, increasing your exposure without you realizing it. That's why skiers and people in snowy places can get sunburned in winter, even when the air feels cold. While the ozone layer is slowly healing thanks to global efforts, temporary spikes in UV radiation can still occur due to weather changes or events like wildfires, which can thin the ozone temporarily. That's why it's important to always check the UV index and take sun safety precautions, no matter what the weather looks like outside. Sun safety should be a daily habit, not just something you think about in the summer. Protecting your skin is important all year round. By protecting yourself from UV rays, you're not just avoiding sunburn, you're investing in your long-term health and well-being. Remember, the ozone layer and your sunscreen work together as your best defense against harmful UV rays. Make them both part of your daily routine. Australia's sunny climate and outdoor lifestyle come with a serious UV challenge. During the southern hemisphere's summer, Earth is closer to the sun, increasing UV intensity. Australia's clean air means fewer particles to scatter UV, so more reaches the ground. The nearby Antarctic ozone hole has also contributed to high UV levels. As a result, Australia has one of the world's highest skin cancer rates. Public health campaigns like Slip, Slop, Slap, Seek, Slide have made sun safety a national habit. Kids wear hats at school, and shade structures are common at pools and parks. No hat, no play is a rule in many schools. This proactive approach has saved lives and set a global example. Adapting to environmental realities is key to public health. Australia's story shows how awareness and action can turn a challenge into a lesson. Sun safety is part of the culture, and it works. The ozone layer's health matters to every living thing on Earth. For humans, it's our shield against UVB, protecting us from skin cancer, cataracts, and immune system damage. Animals, pets, livestock, and wildlife are also at risk from high UV. Amphibians, like frogs, can suffer population declines from UV-damaged eggs and larvae. In the oceans, phytoplankton, the base of the marine food web, are sensitive to UVB, and their decline would disrupt entire ecosystems. Plants on land and sea need stable conditions, which the ozone layer helps maintain. Ozone also regulates stratospheric temperature. The chemicals that destroy ozone, CFCs, are also potent greenhouse gases. By phasing out CFCs, we helped fight both ozone depletion and climate change. A healthy ozone layer means a healthy, functioning planet. Protecting it is essential for all life. Our future depends on it. Let's bust some of the most common sun protection myths using real science and clear facts. There's a lot of misinformation out there, but understanding the truth can help you make smarter choices for your skin's health. Myth: I have dark skin, so I don't need sunscreen. Fact: all skin tones, from the lightest to the darkest, can experience sun damage and even develop skin cancer. Melanin offers some natural protection, but it's not enough. Everyone, regardless of skin color, needs sun protection to stay safe. Myth: I don't need sunscreen on cloudy days. Fact: up to 80% of harmful UV rays can pass right through clouds. Even on overcast or foggy days, your skin is still at risk for sunburn and long-term damage. Don't let the weather fool you. UV exposure happens year-round. Myth: high SPF means I can stay out all day. Fact: no sunscreen blocks 100% of UV rays, and its effectiveness fades with time, sweat, and water. You need to reapply every 2 hours, especially after swimming, sweating, or towel drying. High SPF is helpful, but it's not a free pass to ignore reapplication. Remember, sunscreen is a tool, not a suit of armor. It works best when combined with other protective measures. Make sun protection a daily habit, just like brushing your teeth or washing your face. Consistency is key to keeping your skin healthy. Don't rely on SPF alone. Add hats, sunglasses, and seek out shade whenever possible. Layering your protection gives you the best defense. Sun safety is for everyone, every day, no matter your age, background, or where you live. Protecting your skin is a lifelong commitment. The right habits now prevent problems later. Taking a few minutes each day can save you from years of skin issues down the road. Knowledge is your best defense. The more you know about sun safety, the better choices you can make for yourself and your loved ones. Enjoy the sun, but always respect its power. A little caution goes a long way toward keeping your skin safe and healthy. Smart choices today keep your skin healthy for life. Protecting yourself now means you can enjoy the outdoors for years to come. Trust science, not myths. Following evidence-based advice is what truly keeps you safe under the sun. The Montreal Protocol is a landmark in global cooperation. When scientists identified CFCs as the cause of the ozone hole, world leaders acted. In 1987, every UN country agreed to phase out nearly 100 ozone-destroying chemicals. Developed countries led the way, while developing nations got support and time to adapt. The treaty sparked innovation. New, safer technologies replaced CFCs. A special fund helped poorer countries transition. The Montreal Protocol proved that international agreements can work. It's a model for tackling other global challenges, like climate change. Courage, science, and teamwork made a real difference. The ozone layer's recovery is proof that united action can protect our planet. The ozone layer's recovery is a beacon of hope. It shows that positive change is possible when we work together. The sky is healing, and our future is safer. But the journey isn't over. We must stay vigilant and honor our commitments. Practicing sun safety is our daily contribution. Every small action adds up to a healthier world. The Montreal Protocol's spirit should guide us as we face new challenges. You have the power to make a difference. By learning, acting, and sharing knowledge, you help protect our planet. The adventure continues, and you're a vital part of it.